Welcome back, boys and girls. Today's Monday, April 6th. Before we start today's lesson, I want to remind you on a couple of things. So I don't know if you saw last week's videos and caught on that Ms. Medina teaches Mondays and Tuesdays, and Ms. Garcia teaches Wednesdays and Thursdays. And then on Friday, you have assessment day. So I wrote this down on this calendar, and I have provided this calendar to your parents. So this Friday, you will not have an assessment because it was scheduled to be your day off. So just a reminder, this Friday there is no assessment. So you're going to have 4 lessons for this week. And you're going to have lesson 8, 9, 10, and 14 on Module 5 book. Also, for this week, there will only be a do now on Monday. No do now on Tuesday, Wednesday, and Thursday. Shout out to Ms. Fernandez, a parent, for letting me know that the week 1 do nows were the same as the week 2 do nows. And I apologize for not catching that sooner. So again, for this week, there are no do nows, only today, Monday. That's the only do now we're going to do for the multiplication T-chart. Another reminder, the examples that I solve on the videos are not the same ones in your book. So I want to remind you that they're different. And this way, I don't show answers to you, and I don't give, and you have enough problems to solve on your own. So again, this is the calendar. You can pause this video right now. You can take a picture with your phone, your iPad, or tablet, so that you have this calendar easily accessible and you can know which lessons are due on which day. So you are responsible for completing lessons 8, 9, 10, and 14, but at the end of the week, you're responsible for submitting exit tickets for lessons that are highlighted in orange. For example, for this week, lesson 9 and lesson 14 are the only 2 exit tickets that you're going to upload for this week. You can upload them. You have until Friday to upload them. Those are the only ones that I will be providing feedback on. All the other ones still need to be submitted, but I'm not going to be providing feedback on them unless I notice that you made a lot of mistakes or you needed more support. Then I'll reach out to you so that we can schedule a video chat and go ahead and I can reteach anything that I need to reteach to you. So let's begin. So boys and girls, as you're seeing on the screen, every Monday you are to complete the multiplication T-chart. I ask that you time yourself 5 minutes and that you work on it in less than 5 minutes. We've been working on this from the beginning of the school year, so by now you've already mastered the goal of completing the 6, 7s, 8s, and 9s in less than 5 minutes. So right now what I ask you to do is go ahead and pause the video, work on the 6s, 7s, 8s, and 9s, and when you're done, you may play the video to see the answers. So click pause. Okay, boys and girls, so these are the answers to the multiplication T-chart. Go ahead and grab a pen and grade your work, and if you have any mistakes, go ahead and fix them with your pencil. I really hope that you were able to complete these in less than 5 minutes. If you weren't, please take some time later today to go ahead and time yourself again and work on a different one on a separate sheet of paper. So now we will begin with our lesson. Make sure you have your Module 5 book ready with your pencil and any other supplies that you may need. Okay, boys and girls, so go ahead and date it April 6, 2020. Today we're working on Module 5, Lesson 8, the objective. Students will be able to use an area model and multiplication to show the equivalence of 2 fractions. You have 3 key points. Key point number 1, draw an area model. Key point 2, use multiplication to create equivalent fractions. Key point 3, use cross multiplication to check your work. And then you have 3 vocabulary words. The first one is decompose. That means to break apart. Number 2 is compose, to put together. And number 3 is equivalent fractions, which these are fractions that represent the same amount. Since we'll be working with this today, make sure that you write these on your notes. So go ahead and take some time to pause the video to write these notes on your math packet. I'll go ahead and wait as you pause the video. Don't forget to click play when you're ready. Be ready with your pencil and your Module 5 Lesson 8 book. Okay, so let's begin today's lesson. I'm going to draw an area model. This area model represents 1 whole. Now, if I want to partition or divide this into thirds, I would do it like this. So right now we're going to be working with thirds. What fraction do you think each part represents? Think about it. Yes, each part represents 1/3. Make sure that when you are sketching fraction strips or area models to represent parts of a whole, that you label each one inside. I did notice that on these past assignments that you submitted, a lot of you were missing the labeling. So it's very important, and I messaged you, I put feedback that it was very important to label the parts. Okay, so we're going to focus on only one part, which is 1/3. So I'm going to highlight one part. All right, watch as I draw this horizontal dotted line. What's happening to the total units in this whole? I started with 3 units. When I drew the horizontal dotted line, what's happening to the total units of this whole? Yes, there's now more, right? So we originally started with 3 units in the whole, and now we have 6 units in the whole. So we have doubled our total number of units. Okay. Now let's focus on the shaded portion. What happened to these units right here? Yes, we had 1 unit shaded and now there's 2 units shaded. So the number of the selected units has also doubled. I could record the doubling of units using multiplication. Watch. I started with 1/3. I drew a horizontal line, which means that I doubled the units. So I doubled the units. And now I have 1, 2, 3, 4, 5, 6 total equal parts, and 2 of them are shaded. Thinking back to our objective for today, what do you realize about 1/3 and 2/6? What do we know about those 2 fractions? Yes, these fractions are equivalent. So you can create equivalent fractions by multiplying the numerator and the denominator by the same number. It's also important to understand that by multiplying, the units didn't get any larger. This is the biggest misconception that students make. They think that because we're multiplying, it's going to get bigger. Well, you're going to increase the number of total equal parts, but that doesn't necessarily mean that each fractional part, that the size of each fractional part will get greater. Okay, so what we're going to do right now is, if you need to replay this video, you can pause it right now and replay it. But right now I'm going to transfer this learning onto the guided practice. So students, the examples that I'm going to work on right now are different from your examples, but they're very similar. You solve them the exact same ways. The exact same way. So it's very important that you pay attention to how I solve these. You may also, again, I'll remind you that you can pause the video if you need help or if you need to replay this again. Okay, so let's begin. Let's focus on section number 1. The shaded fractions have been decomposed into smaller units. Express the equivalent fractions in a number sentence using multiplication. The first one has been done for you. So let's understand the first one. Let's pretend this dotted line did not exist. So if I look at the whole, how many fractional parts is this partitioned into? 3. That is why we have 3 as the denominator. How many fractional parts are shaded? 2. And that is why we have 2 as the numerator. So what fraction does this model represent? Yes, this model represents 2/3. Now if I draw one horizontal line down the middle, now I have 2 parts. So each fractional part has doubled. So let me verify to see what happened. I have now 1, 2, 3, 4, 5, 6 total equal parts. And how many are shaded? Yes, 1, 2, 3, 4 of them are shaded. So again, when it doubled, we multiplied by 2. The numerator and denominator have to be multiplied by the same number in order to create equivalent fractions. So think about these 2 fractions. What do I know about 2/3 and 4/6? Yes, these 2 fractions are equivalent. Let's try another one. Let's focus on this one. Let's pretend these dotted lines do not exist. Let's look at the whole. How many fractional parts is this partitioned into? Yes, 5. So 5 is the total number of equal parts. That's our denominator. How many parts are shaded? That is correct. 4 of them. 1, 2, 3, 4. Okay. Now I have 2 horizontal dotted lines, which have created 1, 2, 3 sections. So that means that 4/5 is 4 is multiplied by 3, and 5 is being multiplied by 3. So 4 times 3 is 12, and 5 times 3 is 15. So this model represents 12/15. Let's verify. Let's check for our total number of equal parts. 1, 2, 3, 4, 5. Since this row is 5, then we'll count by 5s. 5, 10, 15. 15 total number of equal parts. How many are shaded? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is correct. So 4/5 is blank to 12/15. What do we know about 4/5 and 12/15? Yes, they are both equivalent fractions. Let's try D. Take a look at D. Again, we're going to pretend that the dotted line does not exist. And let's write down the total number of equal parts for this whole. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 equal parts. And how many are shaded? 1, 2, 3, 4, 5, 6, 7. 7 are shaded. And so since it has a horizontal dotted line, that means the parts have doubled. So we're multiplying by 2. You multiply the numerator by 2 and the denominator by 2. What is 7 times 2? 14. What is 8 times 2? 16. Now let's verify to see if there's 16 total equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's verify if 14 are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is correct. So what do I know about 7/8 and 14/16? Yes, those two fractions are equivalent fractions. Okay, boys and girls, now we're going to focus on section number 2. Decompose, which means, what does decompose mean? Yes, break apart. Break apart both shaded fractions into 12s. So we're working with 12s. Express the equivalent fractions in a number sentence using multiplication. Okay, since you're going to have to make these into 12s. But first, let me write the fraction that this model represents. Let's count the number of total equal parts. Ready? 1, 2, 3, 4, 5, 6. How many are shaded? 1, 2, 3 are shaded. So what fraction does this model represent? Yes, 3/6. And we have to convert this into 12s. How do we get from 6 to 12? Yes, you multiply by 2. So remember earlier when I said that the numerator and the denominator needed to be multiplied by the same number? Okay, what are we going to do with the 3? That's right, we're going to multiply it by 2. So what's 3 times 2? 6. So I'm going to draw a horizontal dotted line because I doubled the parts. Now I'm going to verify this fraction to see if this model represents this fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there's 12 total equal parts. Now let's verify if 6 are shaded. 1, 2, 3, 4, 5, 6. That is correct. So what do I know about 3/6 and 6/12? Yes, these two fractions are equivalent. So you will be solving B the same way. Let's solve it together. Let's write down the fraction that this model represents. Let's count the total number of equal parts it has. Ready? 1, 2, 3, 4. How many are shaded? 1, 2. Okay, again, the instructions told us to make it into 12s. So I'm going to prepare and make it into 12s. So how do I go from 4 to 12? Yes, by multiplying by 3. So if remember earlier I said that the numerator and the denominator needed to be multiplied by the same number in order to create equivalent fractions. So what do you think the 2 is going to be multiplied by? Yes, 3. What is 2 times 3? 6. Since we're multiplying by 3, we have to have 3 sections. So we need to divide this whole into 3 rows like this, because we multiplied by 3. Just like this one, we multiplied by 2. We have 2 rows. Here you're multiplying by 3, so you're going to have 3 rows to represent 6 twelfths. Now let's confirm to see if we have 12 as the total number of equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Let's verify to see if there are 6 shaded. 1, 2, 3, 4, 5, 6. That is correct. What do I know about 2 fourths and 6 twelfths? Yes, these 2 fractions are equivalent. Okay, boys and girls, we're now going to work on section 3 right here. But I'd like to remind you that the key points are available in case you need them. If you do not need to follow the key points because you're doing great using just following along with Mrs. Medina, then you're fine. So let's focus on section number 3. Draw area models to prove that the following number sentences are true. So we're trying to prove if 1/3 is equivalent to 2/6. And by doing that, first, I would write this in this way just to see if the numerator and denominator were multiplied by the same number. Okay, how do I get from 3 to 6 using multiplication? Yes, times 2. So I multiply the denominator by 2, then I have to multiply the numerator by 2. Is 1 times 2 2? Yes. So I did just prove that these 2 fractions are equivalent. So now I'm going to draw an area model to show it. So I'm going to start off with vertical lines. I'm going to divide it into thirds. And I'm going to shade 1/3 because that's what this first fraction represents. Again, like I mentioned earlier, it's important to label inside the model. I'm sorry, it's supposed to be third. There, 1/3. Now I'm going to draw a horizontal line because I have to break it apart into 2 rows because we're multiplying by 2. Now I'm going to verify if it represents 2/6 after I have done the horizontal line. 1, 2, 3, 4, 5, 6. Yes. 2 of them are shaded. Yes. So again, what do I know about 1/3 and 2/6? That is correct. 1/3 is equivalent to 2/6. Okay, boys and girls, let's try 3D. So we're trying to prove if 3/6 is equivalent to 9/18. Okay, we're going to use multiplication to see if 3/6 is equivalent to 9/18. How do we go from 6 to 18 using multiplication? 6 times what? Yes, 3. So if I multiply the denominator by 3, then I have to multiply the numerator by 3 and verify to see if it makes sense. 3 times 3 is 9. 6 times 3 is 18. Yes, so 3/6 is equivalent to 9/18. Now I'm going to model this using an area model. So I'm going to represent 3/6. So I'm going to divide it into thirds. And how do we go from thirds to 6? Yes, divide each third into half. Okay, now I'm going to label it. This is 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. And how many do I need to shade to represent this fraction? Yes, I have to shade 3 of them. Okay, so now I've represented 3/6. Now I have to, since we're multiplying by 3, I have to have 3 rows. So I'm going to draw dotted lines to divide it into, well, I'm just going to do a solid line to divide it into 3 rows. That's 1 row, the second row, and the third row. Now I'm going to count. Because they're no longer 6, I'm going to count to verify that it represents 9/18. So let's focus on the total number of equal parts, which is the denominator. Let's make sure that there's 18 equal parts. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That is correct. Let's verify to see if there are 9 shading. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So what do I know about 3/6 and 9/18? Yes, those two fractions are equivalent fractions. Okay, let's move on to section number 4. I would like to remind you, boys and girls, that you may pause this video at any point. You can also replay this. You can replay it to section 3 or section 2 or section 1 if you didn't quite understand it, just so that you can see it more than once and possibly even understand it a little bit better. So let's focus on section 4. It says use multiplication to create an equivalent fraction for each fraction below. So think back, stretch your thinking to the beginning of the lesson. I've been talking about how you can multiply the numerator and the denominator by the same number to generate an equivalent fraction. So that's what this part is asking you to do. And you can use any number you want. Okay, so I want to choose any number. Let's see, I want to choose 5. So what I'm going to do is I'm going to write the fraction, 2/3. Remember what we talked about earlier. In order to generate equivalent fractions, we need to multiply the numerator and denominator by the same number. So since I chose 5, I'm going to multiply by 5. 2 times 5 equals 10. 3 times 5 equals 15. And it's this easy. I have created 2 equivalent fractions. So what do I know about 2/3 and 10/15? Yes, they're equivalent. Okay, let's focus on 4D. Again, give me a number. 3. 10/8. This is an improper fraction. Remember, this is a fraction that's greater than 1. So I chose 3, which means I'm going to multiply the numerator and the denominator by 3 to generate an equivalent fraction. So 10 times 3 is 30, and 8 times 3 is 24. So what do I know about 10/8 and 30/24? Yes, these two fractions are equivalent. So for section 4, it's very easy. In your work, you can choose any number you'd like to multiply the numerator and denominator with, as long as it's the same number. And this is so that you can create equivalent fractions. Again, I'd like to remind you, you can pause the video if you need to. You can replay this section if you need to better understand it. Okay, boys and girls, now we are in section 5. Let me read the instructions. Determine which of the following are true number sentences. So we're looking for the ones that are true. Correct those that are false. So you're going to correct the ones that are not true by changing the right-hand side of the number sentence. Let's see what that looks like. So we're going to verify if 2/3 is equivalent to 4/9. Again, I'd like to remind you that when you multiply the numerator with a number, then the denominator has to be multiplied by the exact same number. If they're both multiplied with different numbers, then you did not create an equivalent fraction. How do we get from 2 to 4 using multiplication? Yes, times 2. So that means we're multiplying the bottom times 2. So 2 times 2 is 4, correct, and 3 times 2 is 9. Oh, that's wrong. So what do we know about 2/3 and 4/9? Yes, these two fractions are not equivalent. Okay, boys and girls, so the second instruction says that we're going to have to correct the ones that are false by changing the right-hand side of the number sentence, this part. So it should have been 4/6. That should have been the correct one, not this one. So this is false. Okay, let's try another one. Let's try B. So we have 5/6, and we're going to verify if it's equivalent to 10/12. What do you think I need to do first? Yes, how do we get from 5 to 10 using multiplication? Times 2, that is correct. So if I multiply the numerator by 2, what do you think I need to do to the denominator? Exactly, multiply it by 2 as well. Now, we're going to verify if 5 6 is equivalent to 10 12ths. 5 times 2, 10, that is correct. 6 times 2, 12. So what do I know about 5 6 and 10 12ths? They're equivalent fractions. So this one here is true, and we don't need to correct anything on this one. So this is what you're going to do, or this is what is expected of you for section 5. I'd like to remind you, boys and girls, please pause this video if you need to. If you need to replay section 5, then go ahead and do it now. Alright, boys and girls, so we have concluded our lesson for today. So go ahead and pause this video so that you can see the next steps. So these are the next steps. 1, you're going to complete all the problem set for Module 5, Lesson 8. If you have the green book, these are pages 53 and 54. If you don't have the green book, then obviously it's called Module 5, Lesson 8, Problem Set. Number 2, complete the Lesson 8 exit ticket on page 55. I believe there's only 2 questions on that. The ones that have the printed copies don't have the exit ticket. You're only responsible for the problem set. And step number 3, you're going to take a picture of the exit ticket and you're going to upload it to the assignment, Module 5, Lesson 8, exit ticket, page 55 on Teams. Again, I just want to remind you that I don't want to receive any pictures of the exit ticket through Teams message or through my text. I want to see them uploaded. Again, if you don't know how to upload it or if you're confused on what to do, my number I have provided here, you can call me to 956-279-6086. I will quickly help you with that. But if you're struggling with the lesson, I ask that you can please replay the video as many times as you want. If that doesn't help, then you can message or call me through Teams anytime from 11 to 12 p.m. every single day so that I can help you with any questions or confusion that you might have with the lesson. So, go ahead and follow these steps. Again, pause the video so that you can understand what's expected of you. Again, you can upload the exit tickets every single day, or you can wait till Friday and upload them all. I will be checking Friday evenings. Every Friday evening I will be checking just to make sure that all the exit tickets are there. If they're not, you will be getting a message from me through Class Dojo, by text, or through Microsoft Teams. And if they're not completed by Friday evening, then they're going to be considered late and I will have to deduct points. So just to be safe, I would say upload them every single day and do not wait till Friday. So again, if you have some sort of confusion or don't understand how to do something, you can call me or you can just message me to my phone number or through Teams and I will respond to your question or concern. Good luck on your lesson for today, and again, pause this video. You can take a picture of this so you know what is expected of you. Bye, boys and girls. We'll see you tomorrow.